All right, we have one more example for perpendicular vectors. In this example, we have a small sailboat that has a velocity of 1.5 meters per second. It heads north across a river that is 1,200 meters wide and has a current of 0.85 meters per second west. We want to find the boat's velocity relative to the shore. So when I do these questions, I like to draw a little diagram. I like to draw what's going on. So we have our water flowing along here. Our water has a velocity or a current, so our velocity of the river is equal to 0.85 meters per second. That's given to us in the question headed west. We know the small sailboat has a velocity of 1.5 meters per second. The sailboat's trying to get across the river. Alright, so that sailboat is 1.5 meters per second. Our resultant vector, our last line, is from the tail of the first to the tip of the last. That there is our ground velocity. So to find this is what you did again in your lab, what we've been doing all day. We're using Pythagorean's theorem. So the ground velocity is equal to 1.5 meters per second squared plus 0.85 meters per second squared. I'm going to take the square root of the whole answer. That gives us a ground velocity of 1.7 meters per second. Now we also need to determine our angle. If you're ever unsure which angle to use, the trick I remember, it's wherever you have two tails. Wherever you have two tails, that's the angle you're going to find. Alright, so our angle, again we're using tan because we're using the information given to us, the opposite and the adjacent. Right, so ka toa, we're going to use the tan. So the inverse tangent is equal to 1.5 meters per second north divided by 0.85 meters per second west. So our angle is 60 degrees north of west. North of west. So we want to take, in our next example, the time it takes for the boat to cross the river. So our river, I'm going to redraw it here. Our river is a distance from one side to the other of 1,200 meters. Going back to grade 10, we have the formula. Speed is equal to distance over time. When we arrange that, time is equal to distance over speed, which our distance is 1,200 meters, at a speed of 1.5 meters per second. The time it will take them to get across is 800 seconds. So the boat, however, with the current, is not going to just fly along in a straight line. It's going to have the current pushing it to the left. So we want to determine the distance the boat lands down the river. So the boat is heading across the river, but it's going to be pushed along this way. We want to find what is this displacement, or what is that distance. So distance is equal to velocity times time. The distance equals the velocity going across. The only one acting horizontally in this case is the current. So it's 0.85 meters per second, and the time it takes us is 800 seconds. That's what we figured out in the last part. So the distance the boat lands down the river is 680 meters. All right, that's it for this topic. Um, Let me know if you have any questions. Hopefully this worked a little better. And we will continue on this way unless I hear any otherwise.